In this video, let us look into the important properties of arcs and angles subtended by them in the circles. So, here is one of the properties. The angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So now this is the property, and this seems pretty simple. Now, let us try to go into a more detailed understanding of this statement. Now, first of all, we need circles now too. Now, before that, this property is subdivided into three properties, which of course means the same, but it's got three variants, if I can say so. So let me first draw three circles. So here is one, here is another one, and here is another one. So now, of course, these circles have the centers O. So now what we'll have to consider in these three circles is, let's first take the first circle and let's consider an arc in the circle. Let's not take the full circle, but let's just consider an arc, a part of the circle, like this. So yeah, here we are. Now, let's say that this arc subtends an angle at the center. And so it does. So you just have to join the ends of the arc to the center and it subtends an arc at the center. So we have an angle here, which the arc subtends at the center. Now what does this statement say? It says that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point of the remaining part of the circle. So here it is. So we've got an arc here subtending an angle at the center. Now let's consider the same arc subtending another angle at another part of the circle, the remaining part, any point in the remaining part. So let me choose that point, say here, for example. So let this arc subtend an angle at this point of the circle. So join the ends of the arc to that point. So let's say the point is here now. Okay, so I'm joining the ends of the arc to this point. So one more line, and here it is. So now this angle is going to be half of this angle. Let's name it. Say, for example, this is A, this is B, and this is O, and say this is C. So angle AOB is going to be double the angle of ACB. Or in other words, angle ACB is going to be half of the angle AOB. That's exactly what this statement says. The angle subtended by an arc of a circle at the center is double the angle. Now, this arc is double the angle subtended by the same arc at any other point of the remaining part of the circle. So, now, this is done. So, we are done with the first kind. In this case, the arc was a minor arc. If you see, there is one arc which is AB and another arc is BA. We spoke only about the arc AB. Now, let's just increase the size of the arc and make it a semicircle. Alright, so let's again name this AB. Now, this is the arc which is half the size of the circle or half the size of the circumference of the circle. So this is a semicircle. So what if this arc subtends an angle at the center? Now, before we go to that, we cannot call AB as a minor or a major arc because it's exactly half in the size of the circle. So the other arc, that is AB, is going to be same as BA. So we can't really split them into minor and major as we did in the first circle. So here it's just AB. And what if AB subtends an angle at the center? How is it going to be? It's going to be like this. You just have to join that to the center, through the center, and then join the ends of the arc. So what angle does this make? It exactly makes a 180 degree angle, like this or this way. Both ways it is 180 degrees. So now, according to the statement, if you make this arc AB subtend an angle in any other part of the circle, that angle formed should be exactly half of 180 degrees. So let's just check that out. So say let's choose a point and let's say this is the point and let's join this to B as well. And let's name this C as usual. So this is going to be a right angle, obviously, because this is 180 degrees. And according to the statement, angle ACB should be half of this, or angle AOB should be double the size of the angle of ACB. So we've got this as well. So the angle AOB is exactly the double of angle ACB. according to the statement. So we're done with this as well. So we've just got another one. I think you can guess it by now. What's it going to be? How different is it going to be? Now the pattern was such that the arcs were kind of increasing their size. First it was a minor arc, and then it became a semicircle arc. So now it's definitely going to be a major arc. It's going to be bigger than semicircle. So let's kind of extend it from here. So yeah, this is the arc, and let's name this AB. So to be really clear here, AB is the major arc and BA is going to be the minor arc. So now what if this arc subtends an angle at the center? So here it is. Just have to join this. And then how are you going to measure the angle? Is it going to be this or this? Definitely it's going to be reflex of angle AOB. It's not the other, it's not the inside of angle AOB. So reflex of angle AOB. Now let us subtend another angle from these 2 points A and B. And let's see if it's going to be half of reflex AOB. I'm sure it is going to be. So here it is. So let's name this point C. So angle ACB is going to be half of the reflex of angle AOB. And it is also kind of almost evident from the way it looks. Although it's not accurate, so you please use a compass, a ruler, and all the required geometry instruments to construct these and verify them with this statement. So the last thing also satisfies the given statement, which says that the angle subtended by an arc of a circle at the center is double the angle subtended by the same arc on the remaining part of the circle. So this completes this simple as well as very, very important property as far as circles are concerned.